Hey everyone, so this is part 4 of our copper on a drone series. And so let me remind you a little bit where we are right now. So we correctly set up copper on the embedded platform. We set up the video for Linux like source. We use the GStreamer copper source to be able to read from video from Linux. It worked okay. It was painful to go there, but we made it. Now, so let's start to make our first like computer vision algorithm, right? Like, or at least integrate a computer vision algorithm. The goal of this for today is to be able to show that to Copper, and Copper should recognize the April tag. And then we'll see, if we have sometimes we'll try to see where it is placed in the space, and maybe some calibration. So we need to know, right, like what's the shape of the camera to be able to for Copper to understand where the tag is. But first, let's focus on just being able to read the video, push that to an April tag reader, and see if we can get an output. A little bit of preparation for that. So I don't want to do that on the little platform. You remember it was kind of painful to compile and so on. So I've adapted my local setup to emulate exactly the format the camera will give us on the platform. So let me show you what I did. In the config, I changed the pipeline. So this one is basically this camera here, right? That I have like duplicated and exposed as a video for Linux source. That's so we can actually talk and show what we have, right? Then I piped in video convert and video scale. You need both to be able to force it to this format. And you remember, this is the format we decided on the little platform. Then there is also a local stupidity. The frame buffer is actually flipped in my source. I just asked the GStreamer to flip it back, and then that's the same thing. It's just like the app sync for Copper. So that's the power of GStreamer, right? You can really compose until you can replicate your parameters from the real world. Now I've also changed something else. You remember, like last time we made it work on the remote platform, and we streamed our rerun on our local desktop. So I switched that back to instead of having like the TCP connect that just do spawn, so the interface just works locally and spawn and then connects locally from Copper. So we are set to actually see what Copper is seeing, and we can start to debug. So let's try this like quickly to see if that at least works locally, right? All right. So yeah, it popped up, and you see. So I limited that at 10 frames per second because I don't want to waste too much cycles. So our stream is actually not too much wasted. So that works. We have basically our source in Copper that goes to our task, and our task sending the black and white picture to rerun. So we see what is going on, going through Copper. Now, okay, something we need to know for when you want to detect April tags in an image, is that we need to have what we call adaptive threshold as a transform. So let me try to see if I can show you. Let me try to see if I can show you a little bit what I mean by that. Okay. Almost there. Let me pop that up. Oh. Okay, I'll put my little tablet so we can I can explain to you what is happening. Let me fix this thing quickly. All right, so we have a canvas we can work on. So what is adaptive thresholding? So when you have an image, like the black and white image we have right now, so you have pixels, right? Like one pixel is basically, let's put a few rows like this, and one pixel is basically a value between 0 and 255, okay? And you have a bunch of them. What we want is basically, so that's from, let's say, from 0 to 255. What we want as an output is basically the same thing, right? So if we, like that. But instead of being between 0 or 225, we want 0 or 255. So basically, we want to saturate, either it's going to be black or white, right? The issue with this is that if we do that like a little bit like naively, if we say, oh yeah, let's put like 127, the middle between 0 and 255. The problem with that is that depending on your like ambient lighting, we could have actually like a very dark picture. Maybe the picture is between 0 and 64, right? So you could say like, oh, okay, cool. We could maybe normalize it, like usually, like you could do that too, saying, oh, you know what? Let's take the maximum on the picture. Let's say the maximum is 100, and let's readapt. Like instead of having, you see a range between 0 and 100, right? Let's say if this is the max of your picture, let's basically scale that up. So this 100 match 255 and 0. That's another possibility, right? We could say basically amplify the output, but it doesn't really work well, because imagine if you have like a scene, right, like with like a bright spot here shining at your face. Suddenly here that's 255, and everywhere else is basically very, very dark. So oh wait. Wait, here we go. So yeah, everywhere else it's very dark. So what there is an algorithm for that in computer vision, is that we basically try to do that locally. So let's say if we want to determine the value of this pixel, right? What we can do is take the mean of all those guys around it, like I don't know, you can take 100 pixel or so, right? And if we determine that pixel is basically on the top of the range of those like those neighboring pixels, okay, that's going to be fully black, and if it's not, it's going to be fully white. So it's really compute intensive, because like at every pixel basically you need to kind of recompute the local mean and just see the contrast basically, right? So it works well for those kind of things, because this is like very dark and this is very light. So if we have like a local thresholding around, that is basically around or within this page, suddenly you'll see the contrast for the black side compared to the white one very well, right? It's going to be a perfect thing. So let's try to do this. So that will be our first step. Try to integrate one algorithm that will do that. Okay, we can stop this. Okay. So for this, there is like a crate called imageproc, and I found a thresholding in there. So let's integrate that crate, pipe it to the thresholding, and try to show this image in Rerun. So we add that to our cargo.toml. I think we need image. Let's add it. It doesn't cost much. And imageproc. I got it. Okay, cool. That's cool. Those AI that guess what I'm about to do. Huh? And yeah, that should be cool. And let's add, while we are here, let's add the apriltag crate. We will use it to actually detect the apriltag then. Okay. Let's see. All right. So next step. Let's add the adaptive threshold algorithm, and what we need to feed it is basically, so they have their own image. I see that in the doc. But what we can do is basically create. So this is basically the raw data of our image. So let's first create an image that is at their own format. So yeah, so it's apriltag image. Okay, wait, no. Let's first do the sorry, the other one. So what we need is those ones. And we take width, height, and we want the gray image. Hopefully that should work. And so here I create like I need gray image somewhere. And gray image. Yeah, that's from image. This thing is right up for image. I'm sure I did that, but okay. It's still not happy. We'll see why. And okay. And then, yeah, that will create, like, that will take one gray image. This parameter is, let's put it there, right? Let's take local threshold size, right? That's what I was talking about, right? That's the area in which we will have our mean that we will compare to the pixel itself. And okay, let's change that. Local. It needs to be an even number, an odd number. Sorry. Okay. What is it complaining about? I think things because it's so big for you guys. I zoom in, so it's not easy to see the error from the compiler. It tells me, oh, you need a vec U8. That sucks. Because it means that we will need a copy, right? We already have like a reference to this, so we need to, let's try .in2. I think it should figure it out. Maybe. Yes, it looks like it figured it out. And then I have a gray image. So what we want to do, what we want to do is to be able to send that also to rerun, and I can do that, or not also, maybe I can use this, right? We see that our source image is correct, so let's see what it does, but I'm not sure what to use there. Let's try this. I didn't like it. Okay, yeah, I didn't do it like the same way. What I did, let's see. Did right log image, but my image, oh, I use this one, which is different. Okay, I create like every time like a new image with rerun. I'm not sure why I need to do that, but okay. Let's show you what another example. I saw working on this. Something like that. Okay, it looks like it works better. Threshold image, okay. Maybe. Oh yeah, that is not good. That with an 8. We should maybe put that as a. I don't know. No, it should be a parameter at some point. It's fine. Looks a little bit better. Okay. Does it compile? Oh, it does. Okay. And if we run it, oh, look at that, perfect. So that's what I meant, like a threshold, local threshold image. So it's weird when you see something natural, but check this out. Should be almost perfect, right? We could put like a little bit larger mean, right? You see that it started to freak out on that side, right? So it's a little bit too small. Okay, let's double it. So instead of where are we? Oh yeah, put that there. Instead of that, maybe we could do, I don't know, 97. Will it work with like this? We might need to tune it. Oh, maybe not. No, that's the same format as the drone, so it should be fine. If we can tune it there, it should be tuned. Oh, look at that. Ah, it's perfect. Almost perfect. A little bit more. Let's do a little bit more. Might not be an issue though, because like that's only when the thing is really close to the drone. Okay, just for the demonstration, so we have something that is actually very nice. Hopefully that's going to be enough for it. Okay, this time it's perfect. Look at that. Look at that. Absolutely spotless. We could try our theory. Like if we, for example, we lower the, let me shut off one light or two and see if that affects the detection. One light is off. Second light is off. Look at that. Even almost, I'm in almost complete darkness. And that works well. That's exciting. I love it. Okay, that's perfect. That's exactly what I wanted to see as an input for this algorithm, right? That's going to be super solid, hopefully. Famous word, right? Like as a roboticist. All right. Yeah. Now, what do we need to do? Yeah, we need to detect and detect this thing. So let me zoom in on this one. Here we go. So this apriltag, use those things. You need to inform it like the type of what it needs to look at, right? It's optimized for a specific tag, right? Like so, if you look at this closely, I don't know if you see it, right? But that's a tag 16H5. It means that that's basically a dictionary mapping those shapes to IDs, right? For example, this one I write that down is 4, right? So I know I have like several ones we can try. Yeah, let's see. What we need. So yeah, this time around we need to use. Like I'm looking at the doc at the same time, right? Like and we need to use this like apriltag image. This guy, right? Like so. Maybe what I will do, because that kind of collides with all those images, right? So I will remove this one that is not useful, and I won't put it there, right? So we don't have like a bunch of images that are colliding, so we are sure about what we are doing. So we have here, this is where we want to detect our things from, right? And we need like so an apriltag image. Okay, cool. And is it correct? What can I do? Yeah, we can do that. Okay, I created an image. Maybe we should we will optimize that later, right? Like we should probably pre-allocate this image and copy into it or something when with this guy, or we'll see, right? For now we make copies. Actually, that's a good like general advice with Rust. Just copy, be like wasteful at the beginning, and then start to optimize after that, right? Okay. Then now, oh yeah, no, this one I need to store it, right? We need to build the detector and to store it at initialization, right? Like we will try to put it there, because that we don't want to recreate every time. We are sure that we don't want to create. Okay, wait, I'm lost. Okay, so what do I do there? So I basically, like I was saying, use the same dictionary as what I used before. When you generate them, I actually added in the repo like the way to actually generate them, or they are standard actually. You don't even need that. Like when I generated them, I use only one bit of correction. at least one, so it can check if that's a valid detection it has, right? And then you build it like that, like there is a builder, like so, and then let's put it here, detector, and it doesn't need to be mutable at all. Let's fix that a little bit. It's ugly. And yeah, I do not have this field, and I'm not sure what it is, the type of this. This, hopefully, okay. My task, that is my task. Okay, cool. Looks like we can record. We can get it. Okay, I have this image. Let's not call that. Let's say proc img, saying like, yeah, that's what we want to use with imageproc. And then what I can do is basically copy it. Yeah, copy. Probably this needs to be mutable. Yeah, what we want to do is to get the slice inside and get the slice of this image that the threshold image, and try to shove it in there. I'm not sure what it is complaining about or what. Let's see what it does. Azimuth. Okay. Ready? Oh wait, no, that's not, I should not follow blindly this. That's because that's a result, right? You see that? Let's unwrap it. Again, at the beginning, we are just experimenting. Let's go with the flow, try it end to end, see if it works, and go from there. Okay, so now we should have an April tag image that the detector can look into it, right? And again, I'm copying from an example, so I don't have to. Small, okay. Yeah, it's not that itself, the detector. Okay, looks like it's compiling. It's always a good, yeah, and why not? Well, let's do. Yeah, we'll do something a little bit different there. Okay, let's go through all the detections, and because the problem is that. What it will return there, if I remember correctly, is basically a list of detection with a kind of a limit, right? Like a certain, a kind of a certainty value. Basically, is am I sure that the detection is certain or not? And I think it's between 0 and some number, and or 255, I believe. So let's see what it does there. Oh. It's called detection margin, but I think the decision margin is actually a function, yeah. And let's say 200, I think less than 200 is like very, oh sorry, it's the opposite, like it's over, like it's close to 255 when it's certain or something. And last time I tried, like this 200 was kind of okay. And let's just print the detection, okay. Exactly, right? So we go through this thing, we detect, and we send the image to rerun. So yeah, it was going very quick. I think we can remove that now. Now that we are transforming and so on, we'll see. But I think we don't need to protect against like the quick. Like copper is like really violent at actually calling you very quickly if you return fast. So yeah, the expected behavior, it should not print anything if it doesn't detect one April tag, and if we see one, it should print something there. Okay, I'm excited. Does it even run? Hopefully we don't do that on the small machine that would take like forever to compile. Okay, so we do have that showing up, and let's see. Oh yes, look at that! It works. It works. Okay, so we got that. Like you see, you saw this. Like that was over like 200 in terms of decision making. Yeah, that's the ID4. So that's the right tag, and you see that it gives you in pixel the four corners of the detection. So wait. Oh no, it gives you the center and the four corners of the detection. So that's cool because like you'll see that it can compensate for the the pinhole model of the camera, right? Like when you calibrate a camera, you try to understand like what's basically the spherical projection basically the camera is doing, right? And onto the sensor. So basically those lines, when you're looking at this, right? If I am on the side, this is actually curved, right? It shows curve while it's in reality it's straight. So you need to compensate, right? Basically for this, and that gives us basically the position of those curves, right? That at the angles it finds there. Let's check quickly, and I think we will stop this episode because already we're half an hour, right? I don't want to bore you too much, and we'll go into a little bit more into maybe the next episode will be about to optimizing a little bit this, right? We've copied stuff like left and right. So let's go into this and just get like some idea about like how long it takes to do this, right? Because if this is too long, imagine this is like a powerful machine. So if it takes like dozens of milliseconds here, it's going to be like way too long for the little computer we have there on the other side. And so one thing I want to check is like this adaptive thresholding. And another one would be, okay, this side from there to there, right? And so I always have the same, so that's threshold, okay. Actually that's detection time here, and that is threshold time. Threshold, yeah, and there, okay. That's my way of like quickly debugging this thing. See what's the ballpark, okay? And let's put that in a R is release. Basically, that's the release time. So we do this. Ooh. Okay, and let's stop. Oh, and let's. Ooh, where is it? Okay. Oh, it's not that bad actually. The thresholding, the detection time is 5 milliseconds. It's not bad, right? It's not bad, 5 milliseconds. Maybe it's going to be, I don't know, twice, 3 times slower than this. Even if it's 3 times, it's 15 milliseconds. It's workable. That is not that is not good. Like thresholding should be really quick, right? Like 9 milliseconds. Oh my god, 9 milliseconds to threshold an image. Something is buggy, right? So let's see what they do, because I'm what the hell is going on? So this one is not bad, but this one really sucks. Let's see if we can index and jump in. Oh, maybe yes, it does. It does it? Okay. Tag the block radius, and okay, let's see a little bit what they do. Oh, they create another image. They're get the coordinates. Okay, the block like that. It's probably the bounds right when you are on the top left or top right. Okay, that's just the size. It takes the mean and then test and put a pixel out of this. That's horrible. Okay, so maybe that's going to be our next mission, right? We need to rewrite this. This is unacceptable, right? Like what I would do myself is basically probably if you want to, I would simplify that a little bit. That's maybe too exact. Maybe, for example, this we could skip it, right? Like let's say if instead of for the borders, right? Instead of trying to get only the sub part that is actually valid, just take the one that is always the same size, but or like even if not strictly around, but the corner, right? And also what I would do is I would use vectorization. That could be a good exercise we could do together for the next episode, like showing you a little bit like how I think when I vectorize those like operations on like vector operations, like single instruction, multiple data, so we can go like quickly through those operations. That should be like we could do like 10x or something like very quickly. So yeah, I think it's time to wrap it up here. I think that was a cool one. And the next video will go into optimizing that so we can then try on the little machine, see if we can do this thresholding a little bit quicker. And then the next episode is going to be about like, yeah, can we calibrate and localize those tags from those coordinates to see if we can know what is the pose of the tag or the relative pose of one tag to the camera. Okay, cool. I really enjoyed this. Like if you liked it too, please like it, subscribe to follow for the next episode. I'm trying to make really like snippets like that are independent, that could not be even related to copper. This one, or you could do that. Like if you want to learn how to do like basic computer vision, yeah, that's a cool introduction in Rust. And yeah, please share that with anybody that is interested to actually learn about like how we can do robotics with copper. And if you have any questions, leave comments. I'll follow them. I'll answer all those comments. There's not so many people looking at that, so I can follow now. And yeah, stay tuned for the next one, and we'll go into actually positioning ourselves, and then we'll go into actually like piloting the drone. That's going to be really exciting. So we are getting into the very interesting part of the robotics part of this project. So yeah, thank you so much, and see you on the next episode.